Good day, everyone. I am Edward G. CADIZ Jr. and I am your science teacher for today. Our today's episode is all about characteristics of light. We will discuss the sources, speed, intensity, and color. To grade 7 learners, are you ready to learn? Let's go! At the end of the lesson, you are expected to describe light, explain the color and intensity of light in terms of its wave characteristics, and calculate speed of colors based on their frequency and wavelength. But before that, let us try to answer the following questions. Choose the letter of the correct answer. You are given 5 seconds to answer its question, and you can type your answer in the comment section. Alright, so for the question number 1, it is the smallest unit of the visible light. A. Amplitude, B. Dispersion, C. Wavelength, and letter D. Photons. If your answer is letter D, then you are correct. Good job! Number 2. What is the main source of light energy? A. Sun, B. Moon, C. Stars, and letter D. Planets. Alright, so the correct answer is letter A. Very good! For question number 3, which of the following is considered as artificial source of light? A. Bulb, B. Sun, C. Moon, and letter D. Stars. Great! The correct answer is letter A. Question number 4. He believed that light can be a particle and a wave. A. Isaac Newton, B. Christian Huygens, C. Louis de Broglie, and letter D. James Clerk Maxwell. If your answer is letter C, then you are correct. Excellent! Alright, so let's go to our last question. Question number 5. The brightness of light depends on how far you are from the source. This statement is A. True, B. False. If your answer is true, then you got the correct answer. Very good. If you get all the correct answers, that's great. But if it is not, don't worry because I am here to help you understand. Now, let's get started. Look at the things around you. What makes you see these things aside from your eyes? Correct. It is because of the presence of the visible light. Visible light make us see the things around us. But how does light behaves so that we can see these beautiful creations? Light is an electromagnetic wave. This means that it does not need a medium in order to propagate. Light travels in a straight path. In vacuum, light has a speed of 299,792,458 meters per second. It takes 499 seconds or approximately 8 minutes for light to travel from the sun to the earth. Light is a form of energy made of photons. Photons are the smallest unit of visible light. Our main source of light energy is the sun. The sun is the example of natural source of light. The sun is also considered a luminous body. A luminous body is an object capable of producing its own light. Other sources such as lamps, bulbs, candles are examples of artificial sources of light. Different scientists spend a lot of time in understanding how light behaves. This includes Isaac Newton, who believed that light behaves like particles. Christian Huygens believes that light behaves like a wave. Louis de Broglie, who believes that light can be a particle and a wave. And James Clerk Maxwell, who proposed the electromagnetic theory of light, among others. Their combined investigations enabled us to understand the behavioral light even better. Light is now considered to have a dual nature. It behaves as tiny particles called photons, and it also behaves as a wave. Light is formed by the vibration of electric and magnetic fields. Therefore, it is a form of electromagnetic radiation. The electromagnetic spectrum is where the electromagnetic waves are arranged in increasing frequency. Observe the illustration. Which wave has the lowest frequency? How about the wave that has the highest frequency? As can be seen in the illustration, radio wave has the lowest frequency, and gamma rays have the highest frequency. The only frequency of electromagnetic wave that is visible to human eye is called the visible light spectrum. The visible spectrum is also known as white light. When white light strikes into a prism, it spreads into visible light colors into electromagnetic spectrum. This phenomenon, in which a prism separates white light into component colors, is called dispersion. The component colors of white light include red, orange, yellow, green, blue, indigo, and violet. These component colors are arranged according to a decreasing frequency in a visible light spectrum. Light is a form of energy that travels into electromagnetic waves. It behaves like a wave. Thus, it also has a wavelength, frequency, and amplitude. These properties have something to do with the special characteristics of light, which include intensity and color. Let us first discuss the intensity of light. Light intensity is the power of light. It is the quantity that measures the amount of light illuminating the surface. The science of measuring the intensity or brightness of light is called photometry. Brightness is a qualitative expression of light intensity. It is the visual perception in which a light source appears to be emitting light or a surface to be reflecting light. Since brightness is qualitative and is dependent on the perception of the individual, brightness can be expressed quantitatively using luminous intensity. Luminous intensity is the amount of light that the objects produce. It is measured in terms of candela. The brightness of light depends on how far you are from the source. Observe the following pictures. In which scenario will you see a brighter light? Correct. It is in picture A. The closer you are to the source of light, the brighter is the light that you will see. On the other hand, if you are farther from the source, the dimmer is the light that you will see. Always remember that the intensity of the light depends upon the amount of light or the number of photons that pass a certain area or space. The intensity or brightness of light is also related to the wave's amplitude. The higher amplitude corresponds to a brighter light, while the lower amplitude corresponds to a dimmer light. The next characteristics of light is color. As mentioned earlier, visible light is the only electromagnetic wave that can be seen by the human eye. The component colors of visible light can be seen in a visible spectrum. The color of light depends on the frequency or wavelength of the radiation that reaches the eye. Visible light falls into wavelength range of 400 nanometers to 750 nanometers. What is the color of the light if the given wavelength is between 450 to 500 nanometers? Correct. It is color blue. When the wavelength of a electromagnetic is shorter than 400 nanometers, it is called ultraviolet. And if it has a wavelength greater than 750 nanometers, it is called infrared. Observe this illustration. What can you say about the relationship of frequency and a wavelength? Correct. As the wavelength increases, the frequency decreases. Which color has a longest wavelength? How about the shortest? You are right. Red has the longest wavelength and violet has the shortest wavelength. Now, which color has the highest frequency? How about the lowest? Very good. Red has the lowest frequency and violet has the highest frequency. In general, the color white represents the combinations of all the wavelengths of visible light, while black is the absence of the wavelengths.